Now let's look at some of the other controller methods that are designed to push data to the database. That's the put, post, and delete methods created by the template. This is definitely more interesting than just pulling data back, but we're only going to work with author objects. You've seen that there are a lot of complexities to consider with persisting related data with EF Core, and I don't think that complication is necessary for this fundamentals course. If we're running these methods, we can't just call them in a browser because we have to send along their REST verbs, put, post, or delete, and in addition to possibly adding scalar data in the URI, like we did for getting authors by ID, you might need to also pass data as request bodies through the request header. If you want to learn more about the details of RESTful APIs, this slide comes from Sean Wildermuth's Designing RESTful Web APIs course. I don't want to write a whole front end for this API just to demonstrate these methods, and this is where Swagger can help us out. If you haven't used Swagger before, just follow my lead. I will only focus on the parts that are relevant to the task at hand, so it shouldn't be too challenging. And to make this a little easier, I've changed the default URL for the Pub API profile back to Swagger. The first thing I want to do is add a new author, which means the post author method, and that's tied to the post REST call. Remember that I've refactored the original method to use DTOs, so now it expects to have a simple author DTO passed into it. I'll go ahead and get the API running, and here's Swagger showing us all the methods. Clicking on the bar for post will expand its details, and then we'll go directly to the Try It Out button. There are two types of information to send to REST calls. Parameters, which are scalar values, like the author ID I passed to the get method, and or a request body, which gets passed through the request header. For the post method, we need to send an author DTO object, so that will be through the request body. The Swagger UI has inferred this from the controller method, and notice it says no parameters in the parameters section, but the expected request body is the author DTO. This is another example of the benefit of using the DTO. If this were expecting an author object, you wouldn't be prevented from sending a fully fleshed out object with books and covers and artists, but by using the DTO, I can only send exactly what my code needs. Keep in mind that I'm still working against the sample database, but this is exactly the data that will get passed in, first name string and last name string. And I don't mind because it's just my development database, but you can certainly change the name of the database in appsettings.json if you prefer. And this is the object that will get passed into the post method, which will catch at the breakpoint in the code. So I'll hit execute, and the author DTO object has the values 0, string, and string that we just sent in. If you're following along and aren't able to step through in debug mode and seeing error messages about mysterious edits being made during execution, I had the same problem. What you need to do is disable edit and continue, which you can do by going into Tools, Options, Debugging, General. I'll need to convert that to an author entity. I have a new helper method for that. Then there's some familiar EF Core code to add the author to the DB set and call save changes. I'll run it past save changes to the return, and you can see that the new author ID is now 10, assigned by the database on insert. Finally, the controller method needs to send a response back, and that will be a combination of the newly generated ID from the database and then a new author DTO that I'm creating by using my original helper method to convert from the current values of the author that EF Core was using, and that includes the new author ID. So next, I'm going to open up a second browser window and call the Authors API so we can see the list, and there's our new string author at the bottom. That was easy enough. Let's look at the controller's put method. This one accepts an ID, and that's the ID of the author to edit, as well as an author DTO. I'll stick a breakpoint on the first line of code, and then let's go back to Swagger. I'll expand the put method this time so we can edit that new author. Again, I'll go right to the Try It Out button. This time, Swagger detected that the put method needs that integer as a parameter and an author object as the request body. I know I want to edit the new author with ID 10. Now I'll change the author ID to 10, and instead of my author being named String, I'll change it to Julie Lerman, and then click Execute. Now here I am back in the code at the breakpoint. I can see that the author DTO is as expected, ID 10, first name Julie, last name Lerman. The code then verifies that the ID parameter matches the ID of the object. And again, in order to have an entity that can be used with Entity Framework, I'm using my helper method to convert the DTO into an author entity. Then it uses the entry method, which you've seen a few times already, to set its state to modified, and calls save changes async. The error handler is here in case for some reason that author ID 10 isn't in the database. Otherwise, it just sends an empty response. Looking at the logs after the method is complete, there's the update command with the parameters. After I refresh the list of authors in the Other Browser tab, author number 10 is now Julie Lerman. One more method to go, the delete method. And this one did not require refactoring to deal with a DTO because it only takes in an ID and doesn't return anything. So this is the original method as created by the template. And that parameter is the ID of the author to delete. So we'll go back to Swagger and expand the delete REST call and click try it out. Then I'll enter 10 as the parameter, then execute. The delete method first uses find async to get the author. If the author wasn't found, then it returns the not found method that's part of the base controller object. If it was returned, then this template generated code uses authors.remove to mark it as deleted in the change tracker. Then it calls save changes async. I'll run that the rest of the way, and refreshing the API browser page, author number 10 is now gone. And then looking at the console window, there's the delete call to the database. While I've just used the template-generated version of delete author, I'll do the delete one better and use SQL for the delete to save a trip to the database. Remember, I created a stored procedure for deleting, but that was for covers. So instead of adding another stored procedure so you can see me using that, I'll just cheat here and call raw SQL instead of a stored procedure. In a real application, I would definitely use a procedure, not just put my SQL into my code base. Here I'm using execute SQL interpolated async with an interpolated string delete from authors where author ID equals the ID that's being passed in. And remember, I'm using the interpolated string here so that the ID will be a parameter and I don't have to worry about SQL injection. And with this simple SQL, if I pass in an ID that doesn't exist in the database will just say nothing happened. In other words, 0 rows were affected, as opposed to throwing an error. Instead of checking for a null author, like the delete code originally did, I'll check to see if rec count is 0. Notice that I'm grabbing the results of the execute method. And if that result, rec count, happens to be 0, I'll just return not found. Otherwise, I'll continue on and return no content. In other words, everything worked, but I have nothing to show you. Back to Swagger and the delete method, and I'll just enter 10 again as the ID. Looking at the console, I can see that the SQL I expected was executed, but because I already deleted the author whose ID is 10, that means the record count that comes back is 0, and this time I'll show you the server response directly in Swagger, and it returns the 404 because that ID wasn't found. But the method did run the correct SQL for me. Well, I hope this gave you a great head start on using EF Core in ASP.NET Core apps. Building this app was fun. I think the most important lesson here was understanding EF Core's life cycle in web applications and the importance of using short-lived contexts, asynchronous calls to the database, and non-tracking queries to save time and resources. After the controller was added to the app, you learn about using ASP.NET Core's built-in dependency injection to let the app spin up a new pub context as needed. And you didn't even need to be a DI expert to pull that off. And thanks to the built-in logger, you saw that it's not necessary to add all that logging code into the DB context that we had to for the console app. And that ASP.NET Core outputs its logs to a bunch of different places by default. And you can always configure it to behave differently. For example, we added some logging configuration to the app settings JSON file. While the controller template does create some code to get you started, you can always use your own experience to improve on those methods, or just design controllers to perform other work based on your business needs. And we did do an important refactoring so that we have some important separation of concerns between the controller's interaction with the client and interaction with EF Core in the database. In the next module, we'll focus on testing your applications that are using Entity Framework Core. And along the way, we'll do an important refactoring that not only will make our application more testable, but it will also make our applications have much better design. I've referenced a lot of different resources in this module, including a number of Pluralsight courses, the Swagger documentation, and the Blazor sample application. Here are 2 pages of collected links for you. I'm Julie Lerman, and thanks again for watching Entity Framework Core 6 Fundamentals. Hello, I'm Julie Lerman. Welcome back to Entity Framework Core 6 Fundamentals. Throughout this course, we verified our work and inspected how EF Core was working by running the apps we built, debugging them, exploring logs, and also putting out results to either a console or a web browser. But this can be a cumbersome way to test the real software that you're building. And automated testing is an important skill for validating that your code works, as well as ensuring that it continues to work as you make changes to your code over time. There are plenty of courses on Pluralsight about automated testing, including one that I created called Automated Testing for Fraidy Cats Like Me. However, you can still follow along and be able to understand the basics of how to test with EF Core. What we'll be doing in this module is start with a very quick overview of automated testing, and then I'll share with you what it means when we talk about testing EF Core. Then we'll create some tests that interact with EF Core, either directly or indirectly. The first one will use the SQL Server database in its test. Then we'll switch to EF Core's in-memory database provider for running your tests against EF Core logic more quickly. You'll see the basics of how to use the in-memory database provider and then add some tests into the solutions we've been working with throughout this course. And in both of these solutions, we'll start with some refactoring to make them more testable, and then get a high-level look at how to structure automated tests against the logic in your app that involves EF Core, whether that's with a connected app like the console app or a disconnected app like the ASP.NET Core API. So let's get started. If you haven't done any testing before, I want to be sure you understand a few very high-level concepts about testing. One of my favorite courses I ever created for Pluralsight is called Automated Testing for Fraidy Cats Like Me. Even after gaining decades of coding experience, I didn't have much experience with testing and had felt intimidated by it. So I created the course to help developers just wrap their heads around the basics so they would feel more comfortable diving into deeper learning. And I invite you to watch that course, but in the meantime, I'll just tell you about a few ways of automated testing. And automated testing is how we describe testing where you're not just opening up your application and typing into it to see what happens. You've probably heard the term unit testing most often, and most frequently, it's used to refer to any and all automated testing. But unit testing is just for testing small units of logic. That's likely code that you wrote. It shouldn't have any dependencies on anything else. For example, if you've got a constructor that sets values of an object, then you might have a unit test that instantiates that object and then tests that those properties did get properly set. An integration test verifies how your code's working in combination with some other code or service. An oft-used example is testing out code that interacts with a database. Does a query executed on the database actually hit the database, or does it bring back the right type of data? Functional tests are like integration tests, but they verify that a certain set of functionality in your app, possibly a combination of components, perform a particular process correctly, maybe even testing that expected data is correctly returned. There are so many other types of automated tests, like user interface testing,